You can see my screen?
Yes.
Okay. Okay, uh, let's just start. Okay, thanks all of you for joining the session. Today, in today's session, I would be talking about the core of the DICOM and the FHIR Connectathon. It's about two things. One is IHE AR profile, and the second one is TID 1500. These are the two things which are heart of this Connectathon actually. So let me start explaining how they are connected actually. So let me start with the IHE. So all of you are aware of IHE, right? What is IHE and how it is playing a important role in overall interoperability? I assume you know, but in any case, I will just give a small background of what is IHE. IHE is integrating the healthcare enterprise. What does that mean? It's an initiative by healthcare professionals and industry so that everybody come together to define the way healthcare communication works actually. Healthcare, how do you share the information? So so that you have participating systems, we call it as actors, for example. So you have in the PACS workflow, you have PACS system, you have radiology display system, you have modalities. How do they work together? That's what is captured in this, or the mode or the guideline is defined in IHE. So IHE uses this standard like DICOM, HL7, or other things like W3C and some security standards. So everything will come together to define how these actors will talk to each other. So the advantage of IHE is if you are developing a product which follows IHE standard, then one thing, it is easier to implement because there are well-defined communication protocols. There is an echo. I would suggest to please mute yourself if you're not asking any question. If you have to ask question, please feel free to unmute. Okay, I'll not be able to see the chat, but I will try to have it somewhere on the other monitor. Yeah. Okay. Thanks. So yeah. Yeah, so actually, it allows you to develop the system, which is very easy to implement, and most importantly, it helps you to transfer the information effectively and efficiently. So let's assume that you want to replace a particular system in that workflow. It is much easier to replace that workflow because everybody is following a specific communication protocol standard. And if you replace, let's say, Philips with the Siemens, Siemens with GE, then it's much easier to continue the workflow. So that's about the workflows, the IHE part. Then what about IHE profile? IHE, we know these are general guidelines which we are going to do it. But what about IHE profile? IHE profile is nothing but it's a kind of a well-defined documentation for the specific workflow. If you are following workflow, in this case, I'm explaining about AIR, which is AI result workflow, which will talk about how different actors will talk to each other and what is let's say activity which will happen between them and what standards they are using, how the communication data or the data will be flowing between each other. So this is what is a profile. So it's a precise definition of how standards can be implemented to meet specific clinical needs is IHE profile. Now let's go to IHE Air. So we know why IHE is needed, then we know why IHE profile is needed, and one of the profile which is important to us is IHE AIR profile, which is AI results. What is this AIR results? Why is it really needed? What was the intention or intended use of this profile? Main intended use of this profile is to address capture, distribution, display of medical imaging, analysis results. See, nowadays everybody is coming up with the AI software, analysis software, which are generating lot of results, which are lesion indicator or measurements on the images. All are developing this software, and these are very good for kind of aiding radiologist. But if you want to make use of those systems, there has to be some standard way of communication. So one thing is the one usage of this IHE Air profile, AIR profile, is to have interoperable results. What does that mean? So you see that the radiologist will be reading in their environment, and this AI system, generally cloud system or independent standalone system, they are generating the results based on the images which are sent to them. So the results, whatever we have generated, or the systems which are generating these results, should be compatible with the radiological reading workstation, which are already there in the market, already there in the system actually. So that interoperability for sharing the AI results is one prime requirement for IHEAR. Then the next one is second one is on the study integrated results. What is this study integrated result? So generally, if you just ask any radiologist, they would like to view these AI results as a supporting or a supplement result rather than replacing them actually. So it is not that this AI system will replace a human radiologist who is doing the wonderful work now. So it is only that uh, radiologist, when they are doing their work, they use this result, the image analysis result, as a kind of a supporting, just to either cross check or to verify if they have not missed anything, or sometimes take a suggestion from the such system is what is the use case. So in order to do that one, they will need all this information together. So that means study, which is images, you have AI results, and also a radiologist will be working on specific images that also will generate some, let's say, presentation states, PRs, which are again helping. All of these things have to be together. If you have to be together, there has to be somebody who is defining how these things have to be kept together. That is IHER. And the next one is effective presentation. See, at the end, it's all about how do you view this data. Somebody AI application has developed a result, and then you have a radiology reading workstation. So those things have to come together. So that means you should be able to see those measurements which are identified, the lesions which are identified by the AI system on the images for the radiologist. So that effective presentation is also important. To make that one, somebody has to again define how do you present all these results on the display actually. So that's also this effective presentation, or this display primitives last point, are kind of going together. And how about convergence of result encoding? See, even AI system, they also, it is not that they will develop or produce these results from the first day. They have to be trained. Somebody has to train. Most often it is humans who will be training with the large annotations, or the results which are already available, that will be fed to these systems to provide kind of a training documents, which is helpful for them actually. So for the AIs to learn. So if you have this standard mechanism, even AI systems can use the results generated from other AI systems as well. So it is all about how do you tune your algorithm, how do you make your algorithm efficient so that it starts predicting or detecting more accurately and efficiently. That is what finally matters. So this convergence of result encoding, if you know there is a standard way of encoding, everybody can follow the same thing, and then finally you will be using all this system together with some standards. So finally, if you just see this IHE AR profile, it defines how AI workflow should be implemented, how it should be communicated. So now, generally, whenever you define a particular IHE profile, you can also tell, or you should in fact tell what are the different actors and what they are communicating. That's our next step, where we'll define who are the actors and how they are communicating. Let me also ask you, I'll not be able to see the questions if you are posting it on chat, because I'm more focused on this monitor. Either you can ask directly, or we could reserve some time towards end and have a discussion. Either way is fine to me. If you want to ask questions in between, feel free to do so. Okay. Next, let's understand what is this IHE AIR in detail when it comes to actors. So any IHE profile you see, this diagram you must be familiar already. This kind of a diagram you must be already familiar, where you see that there are various actors who will have a specific role to play, who will have specific communication to do, who will have specific needs from other actors in order to fulfill the requirement or fulfill the workflow. So in this workflow, so we have four actors. One is evidence creator, image manager or image archive, image display, and image document consumer. What does that each actor do? So let's take evidence creator. Evidence creator, it's basically the one who create the, so he's a source of this AI results, who creates those results. So images are sent to this system, AI system, and AI system generates those results by doing whatever algorithm it is intended to do, and it generates the result. This is what is evidence creator. And when it creates the evidence, it uses in our profile, it uses a DICOM SR, which is basically having several template identifiers, which is also called TIDs. The one which we are focusing in this connectathon is TID 1500. So evidence creator has to create a DICOM SR which is confirming to TID 1500. We'll see what is TID 1500 later. The only thing what you have to understand now is evidence creator creates the AI results, and this AI results have to be stored somewhere. Image manager or image archive is the actor where we are giving this AI results, and image manager will store those AI results within itself. It could be a vendor neutral archive VNA, or it could be PAX. It could be anything which makes sure that the results are stored permanently. So this is what is the role of image manager or image archive. One thing we have to note here is it is not about only the AI results in the image manager. You will also get the actual images or the modification done by radiologists. Everything will come together. So the complete combination, the study which comprises of all the images, AI results, and also other human generated results also part of this image manager. So you have generated the result, you have stored it. Now there are two more actors who are consuming this result actually. One actor is image display. The usual radiologist, for example, they will on their system, they will pull the images and the result, AI results from this image manager, and display it. How do they display is defined in this uh, AIR workflow or profile. How do they display, and how do they transform, encode, or decode? Encoding is already done here by the creator, and the decoding and the display part is taken care by image display. So here it will also take care of image display and correlating the results which is generated by AI, and together it will be displayed in this image display actor. Then the next one is next actor is this is an important actor nowadays with all clinical decision support system coming into picture. This is very much important. This actor is called imaging document consumer. So this actor is generally used for the use cases where display is not required. So that means you have the information, but you don't have to display, but you use that information for various other reasons. One example is I give on the clinical decision support system. If you have a CDS application, it can actually use this results coming from this AI results, and based on that measurement and other details, it can suggest you what are the next clinical decisions, like diagnostic decision it has to take, or it has to take care of a therapeutic decision. So that action is that use case is satisfied by this imaging document consumer actor, which will get the AI results and display in a different ways actually. And usually CDS application, they use some kind of a cartoon, and on that cartoon they highlight the lesion, they highlight where and all, for example, if it's a cancer application, where and all the cancer is spread, how big is that cancer, everything will be shown on the cartoon on the CDS application. And then they will display what is the next step, whether biopsy has to be done for that patient, or whether the patient has to go for therapy immediately because the result already shows that cancer stage is so and so. So this kind of a use case is done by this imaging document consumer. It could be even clinical databases which takes that information and store that information, or some report creators actually, which basically fetch the details like images, other clinical information, results, everything together. They form a nice report which has all the required details, and that report is one of the artifacts which gets generated in this workflow. So it's very important that this imaging document consumer is integrated in that AI workflow. So just imagine you have a EMR system, and the result what is coming from this DICOM is converted into this FHIR observations, and it is stored. Then the entire clinical system will be easy to use. I mean, they will be really it will be easy to use those information and display it in clinical systems. That's the use case of imaging document consumer. So AI results are generated, they are stored, they are displayed, and apart from display, any other use cases is taken care by imaging document consumer. So one another important, when you see any IHE profiles, is that it also shows how do they communicate actually. That actual sequence diagram will give you a picture how the communications are happening. Wherever you see this RAD 44, 45 are much more detailed communication details. You can go into the respective IHE profile and read about that communication in detail. But in right now we see two use cases. One is store, retrieve, display use case. Other one is this auxiliary usage. As I said, evidence creator will get the images, generate the result, store that results into image manager. Now, at a later point of time, image display radiologist will basically prepare to review the study. They will get these evidence documents, whatever generated, and they work on that one. They query, they retrieve that one. They finally generate some kind of a result out of that one, and they will be displaying that on their display. This is one use case. Second use case, what I just talked about, auxiliary usage, where image manager will have all these details in TID 1500 format, and image document consumer, for example, CDS application, will use this DICOM web. Yesterday, you would have seen discussion where Arun explained how we can use the DICOM web interfaces to get these results actually. So you make a REST call, you get those DICOM SRs from the REST call, and then first query them, then retrieve them, and then you do the next operation. I'll show you in our workflow what we are going to do, and it's up to imaging document consumer how they are going to use it. Last one in this where I want to explain is when we go this TID 1500, you will understand that we will have this qualitative findings from the AI. You can get measurements, qualitative findings, the exact location where the lesion is found, the regions. There are some how do you identify, and the corresponding image references are as well. All these details are part of this TID 1500, which we are going to convert into FHIR. This is the information. This is the use case actually. It start from IHE AIR, and now let me just show you the diagram which I generally use it for showing our workflow actually. Uh, so let me just show this use case. So this you already know, which I have shown multiple times. Let me just apply that IHE AIR here. Are we really going to do something which is compliant to IHE AIR? The answer is yes. The use case is from emergency scenario. You got the patient going through the scan. Here there are no actor actually which are in our IHE profile, but the images are sent to this AI system and to a pack server, or which is basically the first actor. What first two actors? What you see is one is the evidence creator, the AI system. The other one is image manager or image archive, where images are received, and the evidence or the DICOM SR which is generated will be sent to PACS. Now PACS has images as well as the AI generated result. So we see two actors in whatever we I just explained in the IHG profile. The third actor is here, IHG AR image display, which we are not going to do anything. Okay, I have just shown this as an indication here, but this is one of the actor which will be used in the profile, but our focus is these three actors: evidence creator, image manager, and we are going to develop a component called DICOM to FHIR converter, which is adhering to image document consumer. So how are we going to use this actor actually? This actor, how are we going to implement this actor? This, what does its actor says? It actually has to uh, talk to image manager using REST interface, DICOM web interface, and get the AI results into this component, whatever component we are going to develop, and it is up to us how we want to make use. But in our workflow, for easier demonstration, what we are going to do is we will convert that DICOM SR to a to FHIR observation or imaging study from the study information, and we store that details in a FHIR server in such a way that any FHIR application, FHIR client should be able to read that one and show it. Here, any display we could show it. All the CDS application will use this kind of a component actually. So this is the component which we are going to develop. So now you are able to connect what is IHE, what is IHE AIR, what are the use cases, what are the actors, what is a workflow, and then how we are going to do it in our Connectathon workflow. So this is one part of it. I will go little deeper into TID 1500, but before that, are there any specific questions? Maybe I can pause for 30 seconds.
Yeah, Anand, this is Venu.
Hi, Vinu. Yeah.
So the use case is mainly for Indian audience.
Yeah.
And are there any? So I'm totally new to DICOM. I don't know anything about it. Are there any clinics or hospitals or diagnostic centers that are already implementing IHE?
Yeah. See, all this, including the Siemens one, which I'm not sure if you have heard of this Singo Plaza. This is one of the product which is PAX actually, which implements IHE profile, image manager, image archive. It also implements image display. There are various factors. This is not only one profile. IHE AIR is one profile I explained. IHE has several profiles actually for schedule workflow, schedule procedure workflow. There is a profile. There is, in order you if you want to connect RIS, RIS, HIS, and PACS, and then finally display. There is a IHE workflow. If you have heard about this IHE connectathons, which were the original connectathons, which happens in even in other countries, especially other countries actually, where we participate and do it. And these products are used in Indian context as well. But I'm not. I don't know if there are any small companies in India where they are already developing, but it is a kind of a must that they follow this IHE in a kind of a informal way. If they don't do it, they'll not be able to integrate in our hospital system, because everybody will follow standards, and if you don't follow standard, you will not be able to interpret that.
Okay. Second question is, so IHE has, so it appears that IHE has a mature profile when it comes to AIR and the TID 1500 and all that.
It is not yet actually, so it is
Okay.
it is
Okay.
in the it's in the initial
Or better
thing.
than
Yeah.
FHIR, better than
Uh,
FHIR.
no, they are going together actually. See, if you just if I just show you this one, this is the profile IHE AI result. Okay, so it is still it's having revisions actually. 1.1 is for it is given for trial implementation, which is let's say July 16, 2020. It is given. If you think of other workflows like IOCM workflow or scheduled procedure workflow, all these workflows are there from 10 years, 15 years kind of a thing. Atna is for security. They're there from long time actually. Compared to them, this is quite new.
Okay. Okay. So my
There's a
question
lot
was
of
like,
work going on actually on this one. That's also one of the reason why I picked this topic, where all of us in India we could contribute. Is there is a work going on. There's a person actually, I wrote to him, he replied also, on Jonathan Whitby, I think. I don't know how to pronounce this name. He's a person who is working on converting this. He and together with a working group, FHIR working group, they are converting this. They're using TID 1500 and mapping that one to fire observation. This is what one of the also agenda in our workflow, where we will review their p- so so far whatever generated draft, we'll review them and we'll also give them the feedback based on our experience as well. So it's a work in progress, to answer shortly, Venu.
So, so there is value in creating FHIR resources out of this IHE profile.
Yes, yes, yes. In fact, the products. I mean, just to give a short thing, the products which I used here are the Siemens products. Actually, the ARAD companion is a Siemens product, which is already working in that direction. I mean, we also go to other connectathons or even other this hymns or any such demos. We go there and we demonstrate such things actually.
No, no. So I'm not questioning the IHE thing. So creating
Yeah.
FHIR resources,
Yeah, yeah,
converting
of
it into
course, of
observation.
course. It
Yeah.
it it, it is really useful, and in the next week session, where I'll be going through the IG, actually the implementation guide which is done so far. So you'll be able to connect whatever I am talking about the TID 1500 with IG in the next week. Actually, it is so I'm going this flow wise, sequence wise. Now you that understood the DICOM tools, I'm introducing IG, AIR, TID, and the next session would be how this TID 1500 is connecting to fire observation. We will go through the mapping and we'll add on top of that.
Okay. Okay. Thank you.
No problems. Any other questions? If not, let me jump further actually. So now let's understand what is this uh, overall TID 1500. What does this talk about actually? So this TID 1500, I have created a small mind map to explain this one. Are you able to see it, or should I zoom a bit?
Able to see.
Okay, thank you. Thanks for the feedback. See, okay, this mind map will give you a brief idea because it's a bit difficult to map uh, this TID 1500 with actual DICOM SR, which I'll be demoing it now. First, you have to understand the outline. Then it's easier to dissect and see it. From the outline, if you just see 1000 TID 1500, TID is a template identifier for all the SRs. The structured formatting will be represented in this TID 1500. There are several other TIDs. This is a measurement report. It's this TID 1500 is called one measurement report. This defines how one should generate the result. So this has a root called measurement report document title, and there are different parts. One is on this language of content time. This is basically how what kind of information, what kind of language is used to store the information. Actually, that is one part. Then the second one is about observation context. It gives you details about the context, actually, in which context this DICOM SR is being generated. The details are specified in this TID 1001. And then you have procedure reported, on which procedure or which was the procedure used, whether it is MRI, whether it was CT, what was the procedure which was used to generate the images on which this AI result is dependent upon. So that's one part of information, and the second one is this and image library, which are the images. I'll go through this in detail actually if needed. Most important thing is whatever this exclamation mark is indicated, those are mandatory one actually. So we will go through those mandatory things first, and then the most important group is imaging measurements. So This is the group where the measurements are represented. This has some other sub or children actually. It can indicate what is the algorithm used. It can have this usual DICOM things like planar region of interest, okay, a planar ROI or volumetric ROI details. Most often when we are talking of AI measurement, it is on this actually, which is a measurement group or measurement and qualitative evaluation group. And this has further things where it talks about what is the ID or unique identifier, and then it talks about what are the different measures actually, measurements, the lesion information, all those things will be shown or encoded in this group. So if you just see it, yeah, was there any question? Okay. If you just see, this is at high level, but you should now also understand when somebody says DICOM TID 1500, the first entry point for us should be the DICOM manual, which is published by NIMA. And we should go there and see what is this DICOM. So the one which the mind map which I shown is a simplified version of this specification. Uh, Sorry. And if you just see, the specification also talks about this. So you should know how to read this specification. So if you can just map whatever I just explained on the mind map here. You can see that there's a measurement document title, and then you have this observation context, you have procedure reported, then image library, then you have planar ROI, volumetric ROI, and measurement group. This is the group which is important to us. So that's the reason they say that 1 to 6 group, and then ninth group is what is called as a mandatory group actually. But there are some more relaxation which are done recently, which are even they are removing, for example, some of these things like image library, even the language there, everything is relaxed a bit, but yeah, we don't have to go in detail. So this is at a high level. You see how the TID 1500 measurement report looks at the top level schema or the structure. And if you have to go in detail, how do you want to represent, for example, a prostate volume or a lesion which is detected by AI? If you want to see that one, you have to go in further. If you click this, uh, it will show you the details of 1501 is further represented actually. So TID 15001 will tell you how each measurement. So 1500 is a measurement report, which is consolidation of everything. 1500 is individually inside that one. How do you see, for example, how do you put finding details? How do you put measure? What is the location where the lesion is detected? How do you put, for example, exact centimeters or millimeters of lesion actually? All such things are represented using this 15001. When you start writing the DICOM files, you will have to go through this each of these things and start writing the exact way what is expected out of uh, this specification actually. Let's go through one DICOM SR, which I have got it from one of our system, which has generated some AI result, which is related to prostate cancer. So I have shown yesterday. Arun also was trying to show you this. So this is one SR. Okay, how it is shown on the disk. Disk, it is something like this. SR. I mean, it is just any file, 10 KB file actually. And when you open any DICOM viewer, you will be able to see, for example, what are the different tags, each tag and each tags, meaning, and the value corresponding to it. So this is one way of representing the DICOM SR. I'm using this micro DICOM viewer so that you can see the summary in one shot. I'll also go through individual things and show it, but if you just see the summary, how does it look actually? So this DICOM SR has the details like what is the patient details, the referring physician, studies, series, all these details which are coming from the general DICOM, DICOM image, like you have image module, you have study module, you have series module. All such modules are also coming together and which are put in the beginning of this DICOM SR, or it is put as part of DICOM SR, which will give you the details about patient and the study details. The actual measurement group or actual TID 1500 starts with this. It starts with this content sequence. This is where the starting point for rest all are it's basically the patient details, studies details, and this sequence will, if I just start going into this details, it will give you the details about this SR, what it has generated. I'll go through this one. Let's understand the summary first. This DICOM SR has two measurement groups. So you see that there are two measurement groups. It has two measurement groups. One measurement group talks about what is a site, what is a location, or what is the detail, the organ or the location details where the lesion is found, or the details are found. This is about the prostate actually, and there it has found prostate volume as 96.29 milliliter. This is one finding or one measurement. And second measurement is, it also has pyrites. Pyrites is generally it is generated from and this radiology systems which is related to prostate cancer actually. There is a grade which says pyrites you should have, let's say, specific numbers, for example 1 2 3 4. There's a fixed scale, and which also indicate if it is a 3 it is intermediate, 4 it is the next level high, and there is a specific range actually. So in this case, pyrite detected is 3, which is intermediate. So this is one measurement. What is the second measurement? Second measurement, it talks about the exact lesion. The lesion was found on left posterolateral middle peripheral zone of prostate. Not sure how many of you have seen the prostate organ DICOM images. I don't have that right now, but maybe I can also quickly show you that in case if it is interesting to you. Just I'll show you 1 second. Prostate organ details. I don't have this picture which where I can show you that. Maybe the details I can. I think I have one picture lateral view. I can show you this. So okay, this particular one. Posterior lateral. I'll show you that there's a good cartoon which we can show it in few minutes. Otherwise, I'll have to search that. So in the prostate gland, this you can divide into maybe Vivek, you are in the call. Or Veena, somebody from
Yes,
female?
Anant,
You
we'll
have
be
a
listening with that.
prostate cancer. Uh, the areas, the divided areas. If you have a picture, would it be feasible to cue that to me?
Let me check.
Okay, thanks. So yeah, so you see that the finding site left posterior lateral middle peripheral zone of prostate. This gives exact details of where is that prostate is found, and sorry, where is that lesion found, and which we can further do it. Okay, I think this is good enough. So you see that this is a prostate cancer part. So now you see that these are peripheral zone. Okay, when you say left posterior lateral, I think it is a very, I'm not from medical uh, clinical background. I can say left posterior lateral middle peripheral zone of prostate. It is somewhere here. It is all peripheral zone. It is left posterior lateral, so that's down, and then middle peripheral zone. I think it's somewhere it's shown as here, and this is what is represented as a site in this finding site. And then you have other details, as I said, that pyrites 3 pyrites it gives you kind of a score, pyrite score, which will give you which further is used to detect the cancer stage. And you have the image library, which also gives you what is the modality, what is the study details. So it is linked to two images, actually MR images. So this is one shot you see is a summary, but how it is represented in this DICOM image, you will have to see it again through this mind map. It is much easier to see it through mind map. So if I just shorten this, so you see that in the DICOM file, there will be a sequence. Usually, if you have a loop, then you will use sequence, and loop identifiers or loop count is basically the item. So you have let's say in this sequence there are 4 items. Okay, one talks about image library, one talks about procedure reported, and the other one talks about the measurements. This is the bigger one which talks about measurement. In this measurement group, it talks about finding site, prostate, pyrites, and that left posterior lateral middle peripheral zone of prostate. Now I'll open this DICOM image. Okay, let's open DICOM image here. So DICOM image, this is how it is represented at top level. I'm going into content sequence. This is first sequence. You saw there are uh, four items which I showed here. 4 items. Okay, that is mapped to different colors here. Each sequence item is represented as a different color. So there are I did not put two, or basically seven sequence items are there, and I will go into one sequence item. So this is the first sequence item. The sequence item has again a sequence actually. So this is a sequence. So if I click this sequence, it says imaging measurements. This is the group. If you have seen in the TID 1500, I said there is a group called imaging measurement. So you saw that in the TID stuff, you have a imaging measurement group. This is the group. It is represented here. It is at high level, but it is how it is encoded. And the corresponding value is inside the sequence, which has two sequence items. Okay, which has two measurement groups. So we saw one top level measurement groups. There are two measurement groups. We saw that prostate volume and the posterior lateral lesion finding, that is the second part. So two findings are there. So how it is representing, again name is here, which says it's a measurement group. If I just go in detail, it has several other details actually. So what are these several other details? If I show it in an easy way, okay, this several other details are, so there are two measurement groups. So first measurement group talks about, it says it's a measurement group, and when I go inside, it has details like tracking ID, which will finally later will be observation ID also, then unique identifier, and then you have finding site, you have prostate, all these things. If I just go in detail, it says there's a prostate. Okay, this is a the context part. So now this is a UID reference, this is a tracking ID, this is a tracking unique identifier, and if I go inside this, this is about finding site. So the name will be represented in one sequence and the corresponding value will be represented in another sequence. The finding site is prostate, and this UID reference, this prostate is referring to several images. That's what it clearly indicates. UID, which are the different UID references. This this says this also points to which image SOP instance UID it is referring to, and the number here is your prostate volume. See this volume and the value corresponding to it, 96.29. So the one which we saw in our TID 1500 are this part, the one which is shown in the abstract TID 1500, which is basically the document title, imaging measurements, and then measurement group, and there are several other measurements, is mapped to this DICOM tags A370 sequence. Inside that there is a sequence, it has sequence item, and each one is represented here. You get this point? You have all these items which are AI generated results which are there. So now if I go back, this is one measurement group. I'll go to another measurement group, and it has so many findings. One of the findings is all about this is about the name. It's a measurement group is about the lesion. It has particular UID, and then it talks about uh, the lesion part, and then this is the code which I was showing. Left posterior lateral middle peripheral zone of prostate is encoded in this DICOM file. So what are we going to do? We are going to parse this DICOM SR. We are going to find this information. But isn't that easy? Why are we doing even Connectathon on this one? The whole purpose is how do you encode? This is the standard. It is following this TID 1500 format. Whatever Siemens is generating, Philips should be able to read that one. That is possible only if you are following the standard, which is TID 1500 structured report template format. And if you write like this, anybody should be able to read it. What we are going to do is we are going to convert this DICOM SR into a JSON. We are going to write translator which will convert these things as observations actually, and finally we store that information as FHIR observation. So whole exercise is about this one. You should be aware of how to read this DICOM file, DICOM SR file, and to read this one you should know what is TID 1500. To to understand why TID 1500 is required, you should be knowing IHE AIR profile. AIR, it starts from top to bottom. AIR, SR TID 1500, and DICOM SR. From DICOM SR, it will get converted into observation. Are there any questions?
So I see this. There are a lot of SCTs. So that I assume it's finding site and all those things are SNOMED CT.
Yeah. That's
Uh,
very good question. Maybe Venu, I'll zoom a bit on this one. See, this AR profile and also um, even this TID 1500, they talk about using this units, coding units. Actually, the LOINC is supported. Even for that matter, SNOMED CT. There's also another one famous thing which is Radlex. Actually, this is a radiology coding system. That's also kind of a standard which they see it. See, if I just go back here, if I just want to show one of the sequence, if I just go here, measurement group, if I just show prostate volume, for example, sorry, prostate volume. It uses a different coding format here. The representation, this coding format is NCIT coding format, and maybe I can show the finding site. Where was that finding site? This is a DICOM one. It is here, content sequence, finding site. It was this is the lesion. It uses a Radlex coding format. So this Radlex 38780, it is used to represent lesion. And SNOMED CT. Yeah, this one is from SNOMED CT, left posterior lateral middle, and there are LOINC. I don't know whether I saw it. Yeah, mainly at least Radlex and the SNOMED CT is something which I have seen most actually.
question is then how do we, so do we just take this coding system and dump it into FHIR, or we should make a terminology service in FHIR also?
Yeah, this was also one of the question in previous meeting where we were debating. I just showed this entire picture to terminology team actually. So I was just asking them if we can collectively create this workflow actually. I will show you back that part. There, okay, this, if you just see our FHIR implementation track can also help us on the DICOM FHIR server, and FHIR starter track can help us in creating a small application which you can view, and this uh, this terminology server can represent can help us in that mapping. So this is where I have asked other track leads to also come together if we can collaborate. So we said we will have a separate brainstorming session with at least Dr. Pramod. He said we should get in touch. If any of you are interested, when you please feel free to join. I will publish that discussion. We will also discuss. The another part which I want to also collaborate is on the ABDM track actually. So ABDM track, if you just see, we have this health information provider and health information user. There is, if you go in detail right now, the profiles what ABDM has provided, it is all about embedding thumbnails or images inside the report. There is no clear definition on how you are going to extract these images from a pack server and provide means to view those images on any of the clinical system as well. This is also one of the track where I want to have a brainstorming where we can come up with the flow. So if you just see originally the two workflows I have proposed here, one is this workflow, AI workflow, which we are much more clear with respect to how we are interacting. Second workflow is ABDM workflow, which we can create a workflow where we can share the images in imaging study, and the imaging study, if we can give it to any of this HIUs, that is also one good option. We will have more brainstorming sessions in the weeks, coming weeks,
Yeah, it's like 6 months or a year.
I don't know.
Okay, it is trying to fit in 3D.
At least we will start the discussions. I think
Yeah.
something which comes out. I'm very clear that this first workflow we will be able to achieve. But on the ABDM, at least if you make a proposal in Connectathon, that is still a good achievement in my opinion.
The first proposal should be to make AVD and implement FHIR properly. So,
Yeah.
yeah. Anyway, let me not get there.
Any other questions?
Anand, by the way, we have shared a picture in Teams actually for the cartoon.
Okay, maybe I can. Yeah,
I
share
don't
the
know. I
picture.
was not able to share here to send to
No
you.
issues. I will show it to people.
Okay.
Uh,
Yeah.
you're able to see the screen, guys. So this is how the cartoon would look actually, where the prostate one. I am not still an expert where I can detect where is this posterior lateral middle peripheral zone. Yeah, somewhere it says P is this side. Uh, P is this, and the posterior anterior is anterior, P is posterior. Okay, I think some experts should be able to detect somewhere it should come one of these locations.
I think the colored one shows that location where it is.
Yeah, but I was just trying to map that posterior lateral middle peripheral zone.
Okay.
Okay, anyway, that's not the prime requirement here. Any questions, guys? Anything you want to go in detail, or is it clear? Are there any questions? What I suggest is please, I can also share this DICOM SR on our Zulip channel stream. I will add some of you who are interested. Please, I'll also on the WhatsApp group, I'll ask who is interested, and I take all of them and create a small Zulip stream where we can start looking into uh, this DICOM SR. We start working on the DICOM web interfaces. We'll make small teams who are working towards this. This blue component, which I just explained, this is something which needs some time, some preparation. If we do it, some preparation at least till the last week, I think it would be much easier on Connectathon 2 days to really make this flying. Otherwise, it would be really difficult.
Yeah, so maybe the next session you will be concentrating on Scriban.
Next session, two sessions are there. Next Friday session, we will be concentrating on the mapping actually. The mapping means from DICOM SR, what you saw here, the DICOM SR part. Now I will show one-to-one mapping where I will show how patient details is mapped, or for example, this prostate volume is mapped to a FHIR observation, which field. That is one session. Then on the Saturday session, we will have a longer one where we will take learn Scriban and do a small exercise where we will take only one. For example, prostate volume we create one observation resource out of it. That is our next week's exercise.
Okay. So all the sessions that were done yesterday, for example, Orthanc and all that, is just for getting a context. Right?
Yes, we want to go top down. No, Orthang we'll be using as well. It is not only getting the context. You should be using that. See here, all these DICOM SRs, we'll be storing it here. This component, what we are going to develop, DICOM FHIR converter, will talk to PAC server to get the images from on DICOM
Okay.
SR from
Yeah.
PACs and parsers here. When we write the logic, parsing logic here, there are two outputs here. One is Scriban bit template. The second one is the component which pulls DICOM web interface. The DICOM SR it pulls, it feeds into this Scriban template, it generates, and there will be some more small component here which will push the observations to this part.
Hmm.
Uh, I have to change this arrow. It is actually not pull. It is not push. It is pull. It basically pulls the data and then pushes here.
Okay. And that
Anything
pull
else?
is happening in the IHE profile.
Sorry,
The
sorry,
pull,
Vinu.
the pull is happening in the IHE profile, or is it SR?
No, AR profile is just a definition how it is
Okay.
done. The pull is basically our DICOM web interface. The REST calls which we are making to, which we are going to do for this PAX VNA, that is what is our DICOM web interface, which is defined in AR profile. That all of these things are defined in AR profile. The green blue bubbles what you see are the one which are the workflows which we are going to do using the corresponding tools, and the pink one what you see are the one which are actors as IHE defined, and the DICOM SR is TID 1500, which will be parsing it here.
Okay. So, like you said, Siemens already has IHE, and probably Philips also has it. Is it a fair assumption? Okay.
IHE is any radiology system you take. It's a compulsory if you want to sell it in, at least in Western countries. I mean, unless you pass IHE connectathons, that is a mandatory criteria for even for your initial listing. Actually, the products will not be allowed to bid if you are not passing those IHE connectathons. And if you go to IHE connectathons, once you participate, they'll generate a report. They'll publish that Siemens XYZ Singo Plaza, for example, has passed this. That report is available. Everybody will see that.
So how is it in India? Is it somewhat similar?
India they follow, but I don't know whether India's there are connectathons happening actually. At least I have not participated any connectathon for FHIR itself. I think I participated last year and this year. But even if you just see our connectathons also, we are not really that connectathon where I would have been more happy if we had let's say Siemens coming here, Philips coming here, the G part they would have already implemented, and we on those 2 days we are just exchanging connecting all of these together and running the workflow. That would have been the best actually, but I don't think we are in that stage yet.
So it appears to me that we just sell packs to hospitals and some viewer on top of it, and they get the job done.
Not really. At least some of these products, what you see, GE, Siemens, Philips, which they are selling in India, they also are having IHE thing, IHE profile. It has to do it. Otherwise, the modalities which are sending that, and if modality specific, it is there is a workflow. Modality work list actually, that if it has to work, it has to follow that standard. It will not work otherwise also. As long as you are using HL7 DICOM, that IHE comes into picture and IHE has to be followed. Otherwise, it will not be interoperable.
Yeah. Okay.
Any other questions? In the meantime, I'll
So
stop the recording if you want to continue. Yeah.
I have a query.